Assalamu alaikum dear students, and welcome you all for today's science class. Let's start with the talk of the day. And today's talk of the day is patience is the best remedy for every trouble. It means that patience is not simply the ability to wait for something we desire to achieve. It is basically how we behave while we are waiting or facing trials or difficulties. If you trust Allah and remain calm at the time of trouble or challenges, instead of showing impatient behavior or complaining of trouble or panicking, then no doubt you will get the best results. Allah will give you the reward because of your patience. That's why it is said, patience is bitter, but its fruit is sweet. Allah in Quran says, only those who are patient shall receive their rewards in full with no limit or estimation. That's why it is said that patience is the best remedy for every trouble, right? Students, as you know, we had discussed about reactivity series in our previous lessons, right? And you have seen when you study the reaction of metals with water, acids, and oxygen, you can probably see a pattern. Metals that are very reactive with one are usually reactive with others to a greater or lesser extent. Metals which are unreactive with one substance are unreactive with others too. Let's recall the previous topic. My first question for you is, define reactivity series. Metals are arranged in a sort of league table according to the way they react. This league table is called reactivity series. Second question which you have to recall is, what are unreactive metals? Unreactive metals are those which do not react with anything because they are already stable. For example, gold, silver, and platinum. My third question is, why is potassium at the top of reactivity series? Potassium is at the top of reactivity series because it is a highly reactive metal. That's why it is placed at the top. My next question is, what happens when a piece of sodium is dropped into water? When a piece of sodium is dropped into water, it reacts violently, forms alkali, and hydrogen gas is also given off during this reaction. My next question is, what happens when a gold ring is left in a weak acid? As you know, gold is an unreactive metal, so it will not show any reaction when put in a weak acid. Let's move towards the topic which we are going to discuss today. And the topic for today's discussion is displacement reaction. What is a displacement reaction? A displacement reaction is a type of reaction where a more reactive element displaces a less reactive element. What is a displacement reaction? I am repeating. A displacement reaction is a type of reaction where a more reactive element displaces a less reactive element, right? Let's understand it with an example. In this example, we have element A. As you see, here I am flashing light. Let's suppose this is an element A, and we have also compound BC. We have an element A, which you are seeing in this slide, and we are also having a compound BC. A element is more reactive metal. Element A is more reactive element than B in compound BC. B is less reactive as compared to A. A is more reactive metal than B metal in compound BC. So, because of this, it will displace B. As element A is more reactive, that's why it will displace B and combines with C. Now, B is alone here. You can see B is here. Now, B is alone. So, after this reaction, we have compound AC and we have an element B. These are the products of this reaction. We got AC compound and we also got B element after this reaction. This is basically a displacement reaction. As we saw here, the more reactive element, more active or reactive element A is displacing less reactive element B. Clear? We have seen in this reaction, in this example, that the more active or reactive element A is displacing B, which is the less reactive element, right? And now we have seen after this reaction, we have got a new compound that is AC, and B is left here as an element, right? This is an example of displacement reaction. This is called a displacement reaction. Now, how do we know which element is more reactive than others, right? If you want to know why does this happen and how does this happen, and how do we know which element is more reactive than others, then in chemistry, you know, we have reactivity series, as you are seeing in this slide. In chemistry, we have reactivity series, which we had already discussed in our previous lesson, right? Here, what it looks like for metals, as you are seeing in this slide. In reactivity series, as you know, the most reactive metals, they are placed at the top, and least reactive metals, they are placed at the bottom of this series, right? And as you move down the series, the reactivity of the metals decreases. Most reactive metal, you will always see they are placed, they are ranked at the top of this series, of this list. And as you move down the series, you will see the reactivity of the metals, it decreases, gradually decreases. And when you see at the bottom of this reactivity series or this list, then you will find the least reactive metals and the unreactive metals, they are placed, they are ranked at the bottom of this series. Basically, reactivity series gives us information about displacement reactions, right? This reactivity series, basically it gives information about the displacement reaction, and we can use reactivity series to explain the displacement of metals. Clear? Now let's look at an example of displacement reaction. What happens when an iron nail is placed in a copper sulfate solution? We will see in this reaction that when we put iron nail in copper sulfate solution, then what happens in this reaction? To explain this, first see the reactants of this reaction. These are the reactants of this reaction which you are seeing in this slide. The reactants of this reaction are Fe means iron and CuSO4 which means copper sulfate. So the reactants of this reaction are iron and copper sulfate, right? Now, as iron is more reactive than copper, according to reactivity series, if you observe reactivity series, you know and you will come to know that iron is more reactive than copper in reactivity series. That's why iron is placed at the top and copper is below the iron, as you are seeing in this slide. So after observing this reactivity series, we came to know that iron is more reactive than copper, right? So because of its high reactivity nature, it can displace copper in copper sulfate solution. And the product we get after this reaction, the products are copper and iron sulfate, right? After this displacement reaction, we get iron sulfate and copper as products. Clear? We know that copper sulfate is blue in color, as you are seeing in this slide, and iron sulfate is green in color. So after the reaction between copper sulfate and iron, the product we get iron sulfate and copper. The reaction of iron with copper sulfate, it will give you the color of the new color of solution. The color of solution will change from blue to green, right? After the reaction of iron with copper sulfate, the color of the solution will change from blue to green because the color of copper sulfate is blue, but after the reaction, after this displacement reaction, the product we get is iron sulfate, and the color of iron sulfate is green. So this color change will indicate you that iron sulfate has formed during this displacement reaction, right? Actually, what happens when iron nail is dipped in copper sulfate solution, which is blue in color, then more reactive iron displaces copper from its compound and make its own compound, that is iron sulfate, which becomes green in color, right? So copper will deposit on iron nail, as you are seeing in this slide. Copper has deposited on the iron nail after completing the displacement reaction. You see this reddish brown deposit of copper. This basically the reddish brown color is of copper deposit on the iron nail. This is how iron, being more reactive, displaces copper in the copper sulfate solution. And this reaction is called displacement reaction because the more reactive element like iron has displayed the less reactive element, that is copper, in the copper sulfate solution in this displacement reaction. Clear? Okay, students, I have a question for you that what do you think? What will happen if you put copper in iron sulfate solution? What will happen if you put copper in iron sulfate solution? What do you think? What are the products now? Can you guess the products of this reaction? Yes, no reaction will occur. The reason is because copper is below iron in reactivity series. As you are seeing in this reactivity series, copper is placed over here and iron is placed over here. Copper is placed below the iron. That's why we can say that copper is less reactive as compared to iron. So, as copper is less reactive than iron, so that's why copper cannot displace iron in this reaction, right? So no displacement reaction will take place in this reaction. Displacement reaction only happen when more reactive metal will there to replace less reactive metal. Clear? So students, to sum up, what we have learned today is when a more reactive element displaces a less reactive element, a displacement reaction takes place. Clear? This is all for today's lesson, right? Now, if you have any question, any query regarding today's lesson, you can ask. Okay, students, are you ready for question answer session? My first question for you is, what is displacement reaction? My second question is, what happens when iron nail is put in copper sulfate solution? My third question is, what would happen if silver or zinc were used instead of iron? Now homework time. Your today's homework is that you have to do question answers of test yourself of page 36 of your textbook on your science copies. This homework is also uploaded in Google Classroom. Thank you all and goodbye from my side.